Hello, my name is Ethan Chinnis, and this is Lab 1 Charge Tapes. The purpose of this lab was to figure out the charge of a piece of tape after using a certain method of ripping it from another piece of tape to give it a charge, as well as calculate the amount of electrons that were added or lost to this method. The results were that the tape ended up actually losing electrons, causing a charge of about 1.59 times 10 to the negative 8, and lost about 9.98 times 10 to the 10th electrons, or about 9.2 times 10 to the negative 5th electrons per atom. So these are the physics principles in this lab. Coulomb's law is the main one, which is the force of electricity is equal to this 1/4 pi epsilon naught, which is K, times the charge squared, since both we're assuming have the same charge, divided by the distance squared. There's no r hat here because we're working in one dimension. And we're also using Newton's third law, which is the force of one thing has an equal and opposite reaction with another force. This will be used later to calculate electric force. We're also assuming that the tape is 1 atom tall because it's very thin, and that the tape is 1 gram per meter, which is more of an approximation than an assumption. So to determine the charge of the tape, we charged the tape first of all, and hung it to the side of the table like this, and then it rubbed a pen against hair, so that way it got a negative charge. Then putting it up to the piece of tape, we saw that they attracted, which means the tape must have a positive charge because the pen is negative. So for the actual experiment, the initial conditions are that the system is the floating tape, and the surroundings is the held tape, which we held against it, which caused it to float. The length of our pieces of tape were 26 centimeters or 0.26 meters, and the mass was multiplied by 1/1000 kilograms per meter, because it's 1 gram per centimeter, to become 2.6 times 10 to the negative 4th kilograms. The gravitational acceleration would be 9.8 meters per second squared and constant, and the electric charge of an electron is 1.6 times 10 to the negative 19. For the experiment, we held the tape up against another tape like this, causing it to float, and it floated approximately 3 centimeters or 0.03 meters, which we can then use to calculate the electric force. So first, the force of gravity, which is the mass of the tape times our gravitational acceleration, is 0.00255506 newtons. And because it's just floating in air, that means the gravity must equal the electric force, since it's not moving in any direction. So then we can set this gravitational force equal to Coulomb's law, which is K times Q squared, since we're assuming the tapes have the same charge, divided by this distance squared. And so we end up getting Q is equal to 1.59 times 10 to the negative 8th. And yes, there's supposed to be a little square right here. And the number of electrons is equal to the charge divided by the charge of 1 electron, which we end up getting 9.98 times 10 to the 10 electrons. Then, using the tape's area, which is 26 times 2 centimeters, which is the width, we get 52 centimeters squared, or 0.52 meters, divided by, we're given this in the actual lab experiment, that the tape has a length of 1 times 10 to the negative 10, which we then square to get the area, and divide the areas to get 5.2 times 10 to the 17th atoms. And then dividing electrons by atoms, we get 9.2 times 10 to the negative 5th ratio of electron to atom lost. And then this is the coded model, which you can see the code here. Here's all the initial conditions from before. And PHYS is actually just K. That's just a shortened way to say it. And then you have the gravitational force here, electric force, which is the same as gravity, just not negative. And then this creates the objects here. And you need this R mag here because everything's in vectors, which is, so you turn this R into R mag. And this observation minus the particle right here for R. And then Q is equal to that formula, but reverse solving for Q. And then printed out the tape charge, which is here, which is 1.59 times 10 to the negative 8th. Pretty much the same thing. And the number of electrons, 9.97653 times 10 to the 10th, which is also about the same. And then this just displays all this stuff here. The error in this lab would mostly come from human error, because ripping the tape and handling carefully enough to where the charge is not affected could cause some error between the modeling calculations. However, it seems that they're pretty close in this instance. And furthermore, measuring the distance of the tape, the distance it floats up accurately, was also difficult and could cause error. Furthermore, the humidity on the day was fairly high, which, because the water in the air causes electrons to transfer more easily, which could cause even more error. If the charges of electrons and protons were swapped, nothing would happen, because they would still have opposite charges between the same charge between the tape, which would cause them to repel. an opposite charge to the pen, which would cause them to attract. However, if the pen were somehow still negative, they'd have the same charge and now repel. And it's important to handle the tape as little as possible because our hands act as conductors for electrons, which cause it to be replenished to the tape and reducing its positive charge, creating error. And that is all.